Hello everyone. Today we will discuss about the base segregation. In the base segregation we have the two aspects to discuss. One is absolute amplitude and the other one is the relative amplitude. So first let me explain you what is the meaning of absolute amplitude and relative amplitude. For that first we consider a mass which is being connected to the fixed base with help of the spring and dash part, and we have the figure 2 here where the mass is being connected to the moving support. This is not fixed support, this is moving support with help of the spring and dash part. So the meaning of the moving support is we can consider an example of a vehicle which is being moving over a road with help of the wheels. Here the wheel, it is moving support. So now the meaning of absolute amplitude is if we consider the displacement of the mass as well as the displacement of the spring and dash part with respect to the fixed coordinates of the earth, then we'll be calling it as absolute amplitude. If we consider the displacement of the mass, spring and dash part with respect to the moving support, then we'll be calling it as relative amplitude. Now we will discuss about the absolute motion, that is the absolute amplitude in the base segregation. This is the first derivation. So for that we'll consider a mass which is being connected to the moving support with the help of the spring which is having a stiffness K and the dash part coefficient C. Mass is having the displacement X and the moving support, it is having a harmonic excitation whose amplitude is being given by small y is equal to capital Y sin omega t. Let us write the free body diagram of the mass. Mx double dot and K, this is the difference of amplitude of the mass and supporting element x minus y, C of x dot minus y dot, and hence the equation of motion is mx double dot plus C of x dot minus y dot plus K of x minus y is equal to 0. This is not the forced vibration, this is free vibration where the vibrating structure, it is being mounted on a moving support. Now if we expand this equation, mx double dot plus cx dot minus cy dot plus kx minus ky is equal to 0. Now I will shift these two negative terms towards the RHS. When I shift this term to the RHS, the equation which I am going to get is cy dot plus ky. Since y, the equation given as y is equal to capital Y sin omega t, and hence since y is equal to capital Y sin omega t, y dot can be written as y omega cos omega t. By substituting this y and y dot in the above equation, I will be getting mx double dot plus cx dot plus kx is equal to c capital Y omega cos omega t plus k capital Y sin omega t. So in this I will be taking this capital Y as a common term, so I'll be left with c omega cos omega t plus k sin omega t. Now let us consider a force polygon which we have discussed in the earlier chapters. This is k and this is c omega, which has been, the resultant is supported by an angle alpha. So and hence this one, it is k square plus c square omega square. So now from this triangle we can able to write sine alpha is equal to opposite side divided by hypotenuse side. In the same manner, cos alpha can be written as adjacent side k divided by hypotenuse side k square c square omega square. Let me call this equation as equation 1 and these two as equation 2. Now in the equation 1, now to this equation I will multiply and divide by root of k square plus c square omega square, that is equation 1, it will become mx double dot plus cx dot plus kx is equal to, I will multiply this one by root of k square plus c square omega square, and I will divide this by root of k square plus c square omega square, and the remaining term here I will write it as it is, that is c omega cos omega t plus k into sin omega t. Now further, just I will take this, the term in the denominator inside the square, so and hence c omega root of k square plus c square omega square cos omega t plus k divided by k square plus c square omega square sin omega t. This is what the equation I will going to get. Now here we have this term, that is c omega divided by root of k square plus c square omega square and k divided by root of k square c plus c square omega square. What is this term? It is, this is sin alpha and this is cos alpha. We're going to substitute this sin alpha and cos alpha in the place of this term, and hence we're going to get, when I substitute sin alpha and cos alpha here, I'm going to get it as mx double dot on the LHS, it remains as it is, cx dot plus kx is equal to, this term it will remain as it is, k square plus c square omega square. So here in this place I'll be substituting this one as sin alpha cos omega t plus this term I'll be substituting this one as cos alpha sin omega t. Now this is in the form of sin a cos b, cos a sin b, and hence I can able to write it as sin omega t plus alpha. So and hence I'll be getting it as k square c omega square sin of omega t plus alpha. So here we will be having mx double dot plus cx dot plus kx. This is what a characteristic equation for the steady state base excitation amplitude. So we have the characteristic equation for the force vibration, that is mx double dot plus cx dot plus kx is equal to f naught sine omega t. And for this, the maximum displacement equation is x is equal to f naught divided by root of k minus m omega square whole square plus c square omega square, if you have remembered. Okay, this is what the maximum displacement equation which we have derived for force vibration system. Now here you can compare the characteristic equation of the steady state amplitude with the base excitation and the vibration system with the external force. So here the difference what we found here is, instead of f naught, that is instead of external force, here it has been replaced by y root of k square plus c square omega square. So and hence in the displacement equation, if we replace f naught by y root of k square plus c square omega square, we will be getting x is equal to y root of k square plus c square omega square divided by root of k minus m omega square whole square plus c square omega square. This is the equation which you are going to get. Further, x by y, just I am taking this y to the denominator. So k square plus c square omega square divided by root of k minus m omega square whole square plus c square omega square. This is dimensional form. To make this equation non-dimensional form, I will divide numerator and denominator by k. So whenever I divide numerator and denominator by k, I'll be getting the equation as root of 1 plus 2 zeta omega by omega n whole square divided by root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n bracket whole square. This one we have already discussed in the force vibration derivation. Here x by y is called as displacement transmissibility. It is the displacement ratio, or else it's been called as displacement transmissibility. Where the phase angle can be written as phi is equal to tan inverse of 2 zeta omega by omega n divided by 1 minus omega by omega n whole square. This is what the derivation for the absolute amplitude in the dimensionless form, and this is the phase angle derivation. Now for this we will see the frequency response curve. This is a frequency response curve. On the y-axis we have x by y ratio, that is x is the amplitude of the mass, y is the amplitude or else excitation of the support structure, and omega by omega n, this is a frequency ratio. So here you can observe we can segregate this one into the 4 sectors. One is root 2. This is the frequency response curve, that is amplitude ratio versus the frequency curve. Here you can observe x is equal to y, that is x will become equal to y at the point omega by omega n is equal to root 2. It means for the displacement ratio equation, if you substitute the ratio of omega by omega n is equal to √2, then the equation will become x is equal to y. So here the frequency response curve, we can divide this into majorly into the two zones. That is, what will happen when omega by omega n is less than √2, and what will happen to the frequency response curve when the frequency ratio is greater than √2. So when omega by omega n is less than 2, that is towards the left side of this, so here the frequency response, that is amplitude ratio, that is x by y. X, it is the amplitude of the mass, and y, it is the base segregation amplitude. So the amplitude of the mass will be more compared to the base segregation for all the values of zeta. So at exactly when omega by omega n is equal to √2, the amplitude of the base segregation will be equal to the amplitude of the mass, or else the mass amplitude will be proportional to the base segregation amplitude. And when the frequency ratio omega by omega n is greater than √2, the mass amplitude will decreases when compared to the base segregation amplitude. So, and hence the curve here, you can observe all the curves here, it is having amplitude less than 1. So, and hence we can draw the conclusion here, it as when omega by omega n is less than √2, x by y is more than 1. When omega by omega n is greater than √2, x by y is less than 1. When omega by omega n is equal to √2, x by y is equal to 1. When omega by omega n is equal to 1, x by y is infinity. This is what the inference which we can draw from the frequency response curve. Thank you.